All right, welcome back to another video. Hopefully the first thing you have noticed is that my audio is much better. I realized I have this Tascam recorder that I bought like more than 5 years ago, just laying around, and I just hooked it up through the line out into the audio out, I guess. So I don't know how that works. I wouldn't have expected that to work, but I did do some testing where I can whisper into it and still hear my voice where my laptop would not be able to hear it. The microphone on my laptop would not be able to hear the whispers, but they were picked up by this mic. So hopefully my sound is much better now. Kind of a difference between night and day. So we're moving on to a new topic. This is going to be Bgp Multipath, which is a mechanism Bgp uses for load balancing of traffic. So let's do the reading and then hopefully get through the first example. Understanding Bgp Multipath. Bgp Multipath allows you to install multiple internal Bgp paths and multiple external Bgp paths to the forwarding table. Selecting multiple paths enables Bgp to load balance traffic across multiple links. A path is considered a Bgp equal cost path. It's called cost equal paths in other protocols, but here it's called a cost equal path and is used for forwarding if the Bgp path selection process performs a tiebreak after comparing the IGP cost to the next hop. By default, all paths with the same neighboring AS learned by a multipath enabled Bgp neighbor are considered in the multipath selection process. Bgp typically selects only one best path for each prefix and installs that route in the routing table. In the forwarding table, which is an important distinction to make, because there is a routing table and there's a forwarding table. The forwarding table is what actually sends the traffic. The routing table is just the control information that determines what gets fed to the forwarding table. When Bgp Multipath is enabled, the device selects multiple cost equal Bgp paths to reach a given destination, and all these paths are installed in the forwarding table. Bgp advertises only the active path to its neighbors unless add path is in use. The BGP OS Bgp Multipath feature supports the following applications: load balancing across multiple links between two routing devices belonging to different autonomous systems, load balancing across a common subnet or multiple subnets to different routing devices belonging to the same peer AS, load balancing across a common subnet, load crossing across multiple links between two routing devices belonging to different external confederation peers, load balancing across a common subnet or multiple subnets to different routing devices belonging to external configuration peers. In a common scenario for load balancing, the customer is multi-homed to multiple routers or switches in a point of presence, POP. The default behavior is to send all traffic across only one of the available links. Load balancing causes traffic to use two or more of the links. Bgp Multipath does not apply to paths that share the same MED plus IGP cost, yet differ in IGP cost. Multipath path selection is based on the IGP cost metric, even if two paths have the same MED plus IGP cost. Starting in Junos OS release 18.1R1, Bgp Multipath is supported globally at Edit Protocols BGP hierarchy level. You can selectively disable multipath on some BGP groups and neighbors. Include disable at Edit Protocols BGP group name multipath hierarchy level to disable multipath option for a group or a specific BGP neighbor. Starting in Junos OS release 18.1R1, you can defer multipath calculation until all BGP routes are received. When multipath is enabled, BGP inserts the route into the multipath queue each time a new route is added, or whenever an existing route changes. When multiple BGP paths are received through BGP add path feature, BGP might calculate one add path route multiple times. Multipath calculation slows down the RIB, also known as the routing table, and it stands for Routing Information Base Learning Rate. To speed up RIB learning, multipath calculation can be either deferred until the BGP routes are received, or you can lower the priority of the multipath build job as per your requirements until the BGP routes are resolved. To defer the multipath calculation, configure defer-internal-multipath-build at edit protocols BGP hierarchy level. Alternately, you can lower the BGP multipath build job priority using multipath build priority configure statement at edit protocols BGP hierarchy level to speed up RIB learning. Okay, so now we've got our example here. So this example shows you how to configure BGP to select multiple equal cost external BGP, eBGP, or internal BGP, iBGP paths as active paths. Requirements. Before you begin configure the device interfaces, configure an interior gateway protocol, IGP, configure BGP, configure a routing policy that exports routes, such as direct routes or IGP routes, from the routing table into BGP. So this looks like a really good one to, so it looks like they do give us the topology and they give us the, okay, sweet. So yeah, they're just gonna give us the extra BGP configuration, but all this stuff here, the IGP, just the plain vanilla BGP configuration and the export statement, that's on us, which I'm really happy about. Yeah, so I'm really happy about that because that's the kind of thing that's going to be on the test, just straight up understanding how to do things without it being hand-fed to you. All right, so let's set up this topology here and get that going. So I won't need router 4 anymore. I'm just going to need router 1, 2, and 3. All right, so yeah, and that usually doesn't go away right away. There we go, now it went away. So let's think about the wiring. I want that to make more sense. Right now it's kind of more arbitrary. So I want a wiring scheme that is gonna work. So I can do 0, 0, 1, 1, 2, 2, or I can do 0, 1, 0, 1, 0, 1. Yeah, I'm not sure what I want to do here. I can do 0, 0, 1, 1, 2, 2. Yeah, why don't I just do that? So 0, 0, 1, 1, 2, 2. 001122, perfect. All right, so now I'm going to need to revert the configuration on these. Nice and easy. I don't think I need this light on. Yeah, that's a little better, I think. Okay, so yeah, let's revert these. Hopefully the audio is better. I will be checking that to make sure. I'll be going back and rewatching a lot of this video and seeing if I can make any changes. When I read the documentation, I held it up more to my voice. I can't really do that when I'm configuring the lab, so hopefully it doesn't degrade too badly. Of course, the purpose of making these videos is just to motivate myself to study for this exam and to have something to show for my study, even if I just so happen to not pass, which would be horrible. But if I did all this study, didn't pass, and didn't make a YouTube series, I'd have absolutely nothing to show for it. But now at least I can say, look at all this study I did. Unfortunately, it didn't lead me to pass the exam, but it did, I think, make me somebody at a much higher level than somebody who claims to, or somebody who did not attempt the exam. And you can see, obviously, that is the case based on this video series I made. It's kind of my intention. But of course, I don't want to spend more time on the video series than on the actual exam. The exam is what is important to me. Passing that, not necessarily being the next Dave Bumble or Network Chuck. But I am big fans of those two, and I recommend you go and check them out. Network Chuck's got probably the video I would recommend from him is now Halloween's a while away, it's a few months away, but if you get started now, and you can even do this during, well, they might not even have any Halloween during COVID-19, but the technology itself is really cool. He has a video where he sets up motion detecting Halloween decorations that can spook people. It's really cool. And then David Bumble's one of the most prolific instructors on GNS3 Academy, so he's really got a lot of cred with me because he is kind of the first person you see when you need help on a GNS related issue. And GNS has been kind of a lifesaver for me. It's really empowered me to learn on my own, especially after graduating from networking school and no longer having access to a lab. And especially, I mean, look at what I can do with these VMX images in GNS3. It's like, and I've used Eve. He has videos on Eve too. But yeah, definitely a lot of, I definitely recommend, I'm actually subscribed to them on this channel. So just a nod to them. Yep, they're legit. Check them out. All right, so let's see here. Okay, so now let's okay, so let's do these requirements. So the device interfaces, it looks like they give you the IP addresses they want you to use. So we'll just use those. There is something, so now that we're transitioning over to IP addresses, so we're only 16 minutes into the video, so we've got all sorts of time. This is the hour lunch break. So let's keep on that same theme of kind of regaining those skills that I fought so hard for in networking school, and do 5 more subnetting.net practice questions. So maximum number of valid subnets and usable hosts you can get from /26. So I think they're assuming that it's a Class C range, which would be a /24. So you've got 2 bits for subnets. So the max you can get is 4 out of that. And then you've got 6 bits for host. So the max you can get for 6 bits is going to be, so for 4 bits it would be 240, so it would be 252. Oh, and then these are hosts, so it's going to be 2 less than that. Oh, let me look at the answer. Oh, okay. So, 26. 62. Oh, okay. Yeah, for the subnets, yeah, it's going to be yeah, it's going to be 62. So I won't count that, and I'll keep practicing. This is the point of why I'm practicing this, to kind of get my skills back in this. So enter the last valid host that this is a part of. So 10.89.225, and it's a /28. So we're going to be dealing with toggling bits here. So we got our 8 bits here. Let's represent 255. So here's 128, 192, 240. So 245 is just going to be this bit on. Now it's going to be the third octet where that division is, and it's going to be after the first bit. We know that because of the subnet here. So we know that the last valid host is going to be 1 less than the broadcast address. The broadcast address is just everything to the right of the division line toggled onto a 1. So that would mean everything would be toggled onto the 1 in the third octet, and then everything toggled onto the 1 in the fourth octet. But that's the broadcast address. We need the last usable. So we'll just decrement 1 from that. And we got our first one right. So let's do 4 more. Enter the valid host range for the network that the IP address is a part of. So it's going to be 10.53.223. And it's a /27. So we're going to be dealing with the last octet. So let's do as close to 201 as we can. Or let's represent 201. So here we've got 192. So if we toggled on this one, we'd be too high. We get 224. So this is the 128, 64, 32. So the 16-bit, if we toggle that one on, we're still too high because we're going to have 208, 192, or sorry, 192 plus, So we're going to have 208, which is too high. So what if we toggle on the 8 bits? So then we've got 192 plus 8, so we've got 200. So yeah, that brings us really close. So let's toggle that bit on. And then to get 201, we just have 1 value there, but we've got our line. Here's the 24th bit here. So 25th bit here, 6, 7. So we've got our line right here. So the host address, first host is going to be all the bits in the network portion toggled to off, just 5 bits. So it's going to be .192 is the network address, but we're looking for the first host, so it's going to be 193. And let's look at that again so we can think about, so yeah, so the last host is going to be 10.53.223. And this is going to be 193. Another way to think about it, kind of the way I prefer to think about it, so this is 193, is just know how many apart each subnet is, and you can just think of it through 8, the number of bits that are part of it. So we've got 3 bits that are a part of it. So if there were 0 bits a part of it, we'd have 255 belonging to it. Then we'd have 128, 64, 32. So there's 32 bits that are a part of this. So we know that the networks go every 32 values. So 192 plus 32 is going to be 224, but that's the network address of the next subnet. So 223 is going to be the broadcast. 222 is the last usable in this case. All right, so we got 3 more, I think. So what subnet mask would you use for network so that you can get, okay, so this is telling 10 hosts per subnet. So that's going to be very telling. So we need 12. Yeah, we need a value of 12 here. So if we've got a slash 29, then we're going to have this many hosts in the this many bits in the host field. So we would get 0, 2, 4, 8, 16. Oh, that's interesting. I guess I'm not sure where that 10 is coming from. 10 hosts per subnet. That's interesting. I would think it'd be either 14 or 6 or, well, I guess you get 4 hosts per subnet with a slash 30. Or sorry, you get 2 hosts per subnet with a slash 30. So I think it's slash 28. No, was I right with slash 29? Oh, they want me to actually type it out. All right, so I didn't get that one right. Let's still try to get 3 more right. So there's one more. Oh, good, they're asking me more like this. So 1. So this is a class B. So in order to get, oh, I see. So they're not asking about where you can get exactly 30 and exactly 1710. It's a situation where this is possible. So it's possible if you've got 32 subnets to mess around with. So you would get that with 3 bits to play with. So so it would be 255.255. Now it's a class B address, so it's going to be here. If you got 3 bits to play with, you'd get 2, 4, 8, 16, 32. Well, you actually need 5 bits. So 1, 2, 3, 4, 5. So that's 2, 4, 8, 16, 32. So so it's 128, 192, 240, 248. Yeah. All right, let's get 2 more right. First valid host on the network that the host, that one is a part of. So slash 22, we know it's going to end in .1 because it's going to be the first valid host. We know that the first and the second octet are going to be the same because the slash 22 falls into the third octet. We know that a slash 20 is 4 more than than /16. And we know that /22 is going to be 2 more bits than /40, /20, and a /20 is every 16. So we know a /22 is kind of the equivalent of a /30. So it's going to be every 4, and we know that 64 is kind of a, sorry, 224 is kind of a sticky number in this. So so 224, yeah, it's going to be 4 higher, so it's just going to be 228. So this is our answer right here. So we got one more. This one's super easy. All right, so done that practice. Might be a point, I'm not sure how valuable that really is, but I just kind of felt a little bit embarrassed not being able to just go through those. And even now I got one legitimately wrong. So I'll keep doing that every day. I want to get better at that and kind of have those numbers in mind. I think it'll help for route policies, even though I can probably just use the walk-up knob and not have to do any math or anything during the test. Okay, so time to configure the devices. Oops, this needs to be .2/30. So Juniper, you can put multiple IPs on a port. So I need to delete that one before I add the other one. So let's configure the one to router 3, which is going to be on port 2. Okay, so everything looks good to go. We've got the, so right now, first step, we're just going to configure the device interfaces. Then we're going to configure an interior gateway protocol. Let's go with ISIS because that's probably the one I'm the least comfortable with. So it's the one I want to get the most practice with. Although, of course, it is a bad strategy to only practice what you're bad at, and then you get to the exam, and now you're going to get a average score in something you would have bombed, but everything else where you would have gotten a perfect score, now you also get an average score because you hadn't refreshed it. And before, where you would get a good score for dominating the parts you were strong at, and kind of take a hit on the part you were not strong at and end up with a high score overall regardless. Now you just get an average score because you performed averagely on everything instead of above average on most things, and then a small part of the test below average. All right, so let's see here. Configure private. Oops, I got to do pipe match, G dash. Yeah, and then 0 goes to 1. So edit, set description to R1. edit unit 0, set family address 2/30. Oops, and it's going to be, see, the reason I'm doing it wrong is I'm kind of, in my mind, I'm thinking BGP neighborship addresses. So I'm thinking that I need to set the remote side as what I configure on there. Oh, and this is, yep, this is going to be 1. Okay, so router 2. Top. Perfect. Everything looks good to go. I think. Yep, it does. Okay, time for router 3. Yeah, one thing I was actually thinking of doing is buying a USB mic, but hopefully this Tascam recorder works out because it's going to save me a lot of money. Let's see here. Edit interface. Oh, edit GE002. Perfect. All right, everything is good to go. Yeah. So now we got to set up an IGP, and I'm going to go with ISIS for that. So, and this will be really good because, well, you know, as I said, we haven't gotten to the ISIS section yet, but here we go. So here's the syntax, hierarchy level. So configure interface-specific ISIS properties to configure more than one interface, include the interface statement multiple times. Yeah. See, I wish I could see this example configuring ISIS. So but I think I kind of know what I need to do. So let's go in there, show pipe display set. We're gonna first add it to the interfaces. So edit int 000, and we gotta add it to the unit, I believe. We're gonna do set family, and now it's ISIS is going to be, yep, so ISO, OSI ISO protocol parameters, that's going to be the ISIS. So we're going to apply that. Let's do a run help. Whoops. Well, let's, dang, we can't. Now we're locked out of the help menu unless we abandon these changes. Oh my God. What a nightmare. Yeah, we're locked out of the help menu unless we're no longer in config mode. You can't use the help menu in config mode. Oh, yeah, you can. Yeah, you can. Sweet. Okay, so edit G000 unit 0 help. Aha, topic ISIS. Or help topic family, or help reference family, or ISIS. ISIS, and then here we're doing, well, can we do, how about help apropos family inets? I think this is a regular expression. Yeah. So family inet ISO. Nothing matches. What about for just ISO? Aha, set family ISO. So help reference set, or help topic set, or maybe family help topic ISO. Yeah, ISIS. Yeah, I think this is all we need for this section of the config. I know we need more. I wish I could find in the help menu exactly what we need, but unfortunately, good help is hard to find in this case. They expect you to just memorize it, which of course I will be doing for the exam, but okay. One thing I remember though is you have to have a loopback address for ISIS. You have to configure a loopback interface. So set family, and then it's going to be ISO, and it's going to be address. So now we need, so now I think we can get good help on that. So help reference ISIS address, ISIS family, what about help topic, ISIS address, family, ISIS, let's see here, how about interface? We looked at that before, but let's see if we can get the syntax for the IP address that you have to include on the interface. Sorry, and it's not a IP address, it's an NET address, network entity, but it's a special address for ISIS. So we want to figure out how to do this without using resources that are not readily available during the test. So you can see I'm definitely not ready to walk in and take the test tomorrow. It'd be nice if I knew more about how to get help. Let's read the help menu for help. I don't think I've done that fully yet. Yeah, I don't think I've read this yet. So you can use the Junos Internet Software Command Line Interface, CLI, to configure the Junos software to monitor and troubleshoot the router hardware, the software, and network connectivity. To use the CLI, type a command and press the Enter key. So yeah, this isn't. The CLI provides tab completion for commands to make typing easier. It also supports Emacs style keystroke sequences that you can use to move around on the command line and recall executed commands. Command output can be filtered to a file or to another command. The CLI has two modes, operational and configuration. For more information about these two modes, see CLI modes below, so we won't need information about that. So here we go, using help. Context-sensitive help is available in both CLI modes and at all levels of the CLI. To get help, type question mark. So that we don't need help with. Down here, to get summary information for a specific configuration statement, type help reference statement name. Summary information about the statement from software configuration guides is displayed. So this is definitely what we want. So we want help reference family ISO. Oh, set family ISO. Set. Oh, here's all the options. So okay, but we need it for, so this is close, but maybe topology? Yeah, basically what I'm looking for right now and really not finding is help on this address here, because I want to see, I kind of remember what the syntax is. It's going to be 49.thearea dot an identifier for this particular router, which can be like an IP address that's on it. So like 10.100.100 or something like that. And then a 2-digit 00s. So it would be just something like this. I think would be valid, but I wanted, you know, when I'm in the heat of the moment, you know, stressed out of my mind on the exam, I wanted to be able to give myself a head start of what to look for and how to use the help menu, and I don't want to be doing what I'm doing right now during the test. Or if I have to do this, I want to know that it's going to lead to a result that is going to be beneficial. So what about help reference protocols system? Yeah, I wish I could just get help for, is there seriously no help for address? There is no ISIS address. That's not something they would have thought that somebody needed help with, I guess. People are just that good. I mean, I guess if you work with ISIS enough, there's really no need to have that format reminded to you, because it's just going to be all over the place. But I mean, if you're learning it, it's, I think, a nice reminder to have. I don't understand why this is something that that they would not think people would want a reminder or help for. Yeah, and I don't think it's that helpful to just see what all the commands are, because I can do a question mark. Like, I just want to see what you need to configure ISIS. Like you need, I know you need to configure the interfaces. I know you need to configure a NET address. I know you need to specify what you need to think about, which are your level 1 and which are your level 2 interfaces. But unfortunately, there's just not enough information in here about why you would make one choice over the other, and what is the minimum required. So let me try this. Juniper help for minimum required configuration. So here we go. This looks like a really good one. Yeah, using help commands in Juno. So wouldn't it be great if we could remember every command of boxes? Yeah. See, and this is not what I, yeah. So help topic is the most detailed output. But unfortunately, it looks like the topics that we can get help on are just really specific areas of ISIS. We can't get more basic level help. Yeah, we can't get more basic level help, unfortunately. We can only get really specific help about things that, if we knew about, we wouldn't need help from in the first place. Yeah, I just don't think if you get down and you need this much specific help, I don't think you would need. I don't think the help that they're providing you here would be helpful. But let's just keep going and see if I can form a neighborship just through what I've got here. So I'm going to commit and quits. Aha, so it went through fine. So let's go to router 2, and I'll end the video with this, and we'll come back to this in the after work video. So now I'm going to delete this one because I want to make it different. Okay, and now go up to this one. It's going to be 2, 2, 2, 2. Perfect. So, yep, and now it's time to do family item. Oh, that's interesting. I thought I entered it in there. Apparently I did not. Okay, but now it's in there. That's all that really matters. So hopefully that comes up. Aha, so ISIS instance is not running. That's an interesting error there. You know, this is why that help is frustrating me so much, because I can't get, you know, help on ISIS adjacencies. I can't get help on literally anything that you would think to ask. Oh my God, I spoke too soon. How to configure ISIS. This, oh my God. Configuring ISIS. This example shows how to configure ISIS. Requirements, overview, configuration, verification. It's all right here. Look at this. Gives you the format. Does it even explain the format? Look at this. This is, do they have this for every protocol? That's what I want to know. Aha, so kind of, it's called something else. It's called examples. But this is kind of my, so now we've got enable BGP and define an EGP group that recognizes all BGP systems. And so yeah, this, yeah, so my dream has come true. This is exactly what I wanted. They've got it. So this is all you need to do on device R1 to enable it. So let's see what I was missing on mine. So, aha, so I was missing this set protocols ISIS interface information. So I will send that in there. And we're going to need to add, we are going to need to add the loopback interface in there as well. I literally could not be happier. I honestly thought that there just wasn't a way to get more general help. You could only get very specific help. So I'm very happy that I saw that. And I'm very happy I saw it now in the lab, because if I had gasped out loud during a test. So let's see here, set protocols, interface, oops. I wonder if that, IP address is, aha, so we're in state initializing. So I wonder if the reason it's in state initializing is because I do need an IP address on the loopback. If I do that help command again, help topic ISIS, configuring ISIS, we can see in their example here for router 1, we have both an ISO address and a regular address on the loopback. But nope, it wouldn't just stay up, so that's just kind of extra. It's not completely required. So I think this is where I'm going to cut it for now. I accomplished my goal of trying to make use of that help, and hopefully, if I get stuck in the exam, I can just do a help topic, and let's see, I get stumped on OSPF. So all I need to do is do a question mark from here, then take everything that's in here, which will be, of course, a lot easier in secure CRT, dump it into a notepad here, and then search for configure. So configure timers. What else we got? So search for config. So clear all marks, mark all. So we've got multi-area adjacency, configuring an interface to multiple areas, configuring peers. Yeah, so this is kind of, I think, a way that, is there anything for examples? Oh, there is, so there's 3 matches for examples. Yeah, example authentication, like, yeah, so this is actually going to be very valuable on the test. Oh, and it's 1 o'clock, so I'm gonna log in. Thanks for watching, enjoy, stay tuned.